Okay, so sector area. How do you find the area of a sector of a circle? So this is very closely related to what we did yesterday with the arc length. Okay. So what is a sector of a circle? So a sector of a circle is a region bounded by two radii and their intercepted arc. Okay? A sector is named by the end points of the arc and the center of the circle. For example, the figure here shows sector POQ. So look here, here's POQ. All right? You can kind of think of a sector as like a wedge, like a piece of pie or something like that, right? If you think about a pie, if you look at a pie right from the top down, it kind of looks like a circle. And then if you cut out a big piece of pie right here, right, this piece of pie that you would then like scoop out and eat, that's your sector. Okay, or maybe if you're really hungry, you'd eat this sector over here, right? But this is the sector we're talking about.
No, if you're really hungry.
What's that? Or you eat the whole pie. That's
yeah, if you're really hungry, you eat the whole pie.
But there it is, okay? That's like a sector, okay? Or a wedge, you could maybe think of it as, okay? So, we want to find the area. So to find the area of a sector, we first find the area of the entire circle, okay? So now we have a second formula, right, we should be familiar with. The area of a circle is pi times the radius squared, okay? Remember, circumference is 2 times pi times the radius, but the area is pi times the radius squared. So in this case, okay, what is our radius? 15. So we pi times 15 squared. So we go to our calculator, and I'm going to use the pi button times 15 squared, and you get about 706 point, I'm going to round that to 9, 706.9. Okay, what should our units be for that? Millimeters square, right, because we're talking about area now, it should be square units. So millimeters squared. Now, that's the area of the full circle, but we only want the area of this sector, this wedge right here, the gray shaded in part. Okay, so the entire circle is 360 degrees, but angle AOB measures 120 degrees. All right? Therefore, the sector's area, the area of just this gray wedge, is 123/60ths. Or when that simplifies, 1/3 of the circle's area. So do you get that here? This wedge right here is 120/360, that fraction of the entire circle. And so if we simplify that, it simplifies just 1/3. So this wedge is 1/3 of the area of the circle. So how can we find 1/3 of this area? If the area is 706.9, what can we do to find 1/3 of that? Go ahead, Alex. Divide by? Not divide by 1/3, no. We can, go ahead, Eli. Yep, or just 1/3. So you see here in the book, they just simplified that to 1/3, 706.9. Alex, you were on the right track there, but you didn't want to divide by 1/3, you just want to divide by 3. Multiplying by 1/3 is the same as divided by 3. So we multiply that. Alright, so 1/3 times 706.9 is about 235.6. Okay, and then we already used our calculator to simplify, so we don't need this last part there. Okay, so the area of sector AOB is 235.6 millimeters squared. Okay.
Or it could be.
So for like the A part, it says A pi.
A equals pi times the radius squared.
So we only do that when we find the area?
The area formula is, pi times radius squared. Circumference, right, so the circumference is the perimeter, the distance around the outside, 2 times pi times the radius. So, but since we're trying to find the area of this sector, we first find the area of the entire circle, and then we find the fraction of the circle that is that sector. Okay? Just like we did with the circumference. Let's turn the page here, and we'll find that exact formula. Okay, so in fact, here is our formula. All right, The area of a sector. The area A of a sector with a central angle of m degrees of a circle with radius r is given by this. M over 360, right? We saw that yesterday in our formula for arc length, but instead of times the circumference, we're multiplying it by the area. So it's m over 360 times pi r squared. Okay? So if you look here at letter A, right, we have another example here. So in this case, our wedge is this gray area with an angle of 210 degrees. Okay, so you'll notice they go to the area of a sector formula, m over 360 times pi times radius squared. What's the m in this case? What's our m? What's the measure of our arc? 210. 210. It's out of 360, so 210 out of 360. And then times pi times the radius. What's the radius of our circle here? 3. So 3 squared. See, there it is filled in for us. 210 over 360 times pi times radius squared. And they simplified this fraction here, make it 7/12. And they did 3 squared, which is 9. And then they did 9 times 7/12, which simplifies to 21/4 pi. Excuse me, and at the end they multiplied through by the pi, and they got 16.49. If you want to, folks, you can, at this point, just go ahead and use your calculator. They did some simplification, but really it's not necessary. You can just take this whole thing and type that into your calculator. If I'm here, I'll show you. If I type it in, you got to be careful with it. But if I type in 210 divided by 360, close parentheses, times pi times 3 squared, 16.49, 16.49. Okay? So, all right, let's try this next one. It's got some blanks for us to fill in here. So let's go to somebody. Oh, Ray's not here. Josh is not here. Courtney! All right, Courtney. Courtney's out. All right. Alex! Hey! All right, so So Alex, we want to find the area of sector HGJ. They were very kind to us here. They gave us the grade area to help us figure that out. So it's HGJ, this sector right here. So we start with our formula. Area of a sector is m over 360 times pi r squared. What is the measure of our arc here? 131 times pi times, what's our radius? 12 squared. Okay. So they have us try and simplify this. Let's see here. So 131 divided by 360. I don't think that simplifies. Let me see here. Math, enter, enter. It does not. So we're just going to leave that as 131 over 360. 12 squared, though it does simplify, it's 144. Okay. And then to multiply this fraction together with this whole number, 144, well, to multiply, we can put the 144 over 1. So that means the 131 multiplies with the 144, and that's going to go over 360. So divided by 360, and I hit math, enter, enter, and it's 262 over 5. Okay. Which then really we can just type that whole thing into our calculator if we wanted to there, times, or divide by 5 times pi, and so we get 164.6 about, approximately. Okay, 164.6 square meters. Okay. Questions on any of that?
So it's the 100, like 131 degrees over 360. Is that simplified a whole, like a whole number on that?
Well, yeah, it just doesn't simplify down at all. That's like it doesn't simplify at all. But really, Alex, really, at this point, once you've kind of put things in, you can go ahead and just type this whole thing in your calculator, right? I mean, I could at this point. Actually, at this point right here, I could type in 131 over 360 times pi times 12 squared, right? So I type the whole thing in and just hit enter, and it gives me the 164.6. So you don't need to simplify it down. If you want to just type the whole thing in at that point, you can. But the book had all this space to do it, so I was like, all right, we'll just do it just for kicks and giggles. Dope. All right, let's try one more here together, and then I'll have you guys try one on your own. I did say dope. I like The Simpsons. I don't really watch it anymore, so. Yeah. All right, let's go to Antoinette. So number 4 here, Antoinette. We want to find the area of this sector, and they've graded in for us. So AOB, we want this. It looks like a Pokeball, actually, doesn't it? Kind of.
Yeah.
So anyway, got to catch them all, Antoinette. So here we go. All right. So how are we going to find the area? Let's see. Well, so we know the area is m over 360, right, times pi times radius squared. So what's our m going to be here? What's our arc measure? Yeah, 180. Very good. So you'll notice here, folks, there's no degree measure given, but Antoinette knows this is half the circle, right, creating the Pokeball effect, and it's 180 degrees over 360. Okay, times pi. And then what's our radius here, Antoinette? Is it 1.6? Right. What is 1.6 measuring? The diameter. So folks, again, you got to be on your toes, right? We need the radius for the area of a sector formula. And so the radius is half the diameter. So yes, 0.8 squared.
No, 1.6 half squared.
But isn't 0.8 squared just 1.6? Yeah, no. Remember, 0.8 times 2 is 1.6. 0.8 squared is 0.8 times 0.8. So, yeah, it's 0.64. Exactly right. So we're gonna put this whole thing into our calculator here. So 180 over 360 times pi times 0.8 squared. We're gonna round that to 1.0 square centimeters. Okay, and so there it is. If you left it just as 1 centimeter square, that's fine too. Okay, go ahead and try number 5 there. Go ahead and try number 5. Try number 5. And I'll kind of leave the other one up there for you to see. But go ahead and try number 5, please. Take a second or two. 30 seconds. Try number 5.
There's one that looks like a Pokeball. I think it's like
right, yeah, no, yeah, it looks, yep, I know exactly what you're talking about, yeah. Right. Write that formula up there for you too, just in case. So, what does R stand for? Don't forget the R squared, though. So times, what's your R? Well, look at the picture. What is the radius of the circle? What is the radius measured? Radius is, the radius is from the center of the circle to the edge of the circle, right? Yep. No. 22.5 is a degree measure. That's measuring the angle. 24 is the degree. So that's your R.
How'd you cover Mr. Wick?
Oh, thanks.
Oh, sorry.
Okay, let's go to... Oh, we already heard from Alex. Nope, not yet.
Or have you?
Donovan, what'd you get there for your number 5? What'd you get for your answer? You said 28? Okay, so let's...
I got 28.3.
Okay. So what did you put for your M here? It's... What's the M? What's the measure of our arc? Yeah, that's exactly right. It's the measure of the arc is 22.5 over the 360 times pi and times what's the radius here of the circle? Oh, it's 24. So in this case, O to P is the radius. So it's 24 is the radius. Here in the previous one, Donovan, we had to do half of the 1.6 because 1.6 was the measure from B to A. That's the diameter. In this case, this was the actual radius. So we were just going to use 24. Okay. So 22.5 divided by 360 times pi times 24 squared would yield 113.1. So you had the right idea there, just on the radius. Yep. Which is good. I mean, not good, but I mean, it's good you caught yourself. 113.1 square millimeters there. Okay, should be your answer. Okay, we're going to look at 2 more problems here, and then we will get you guys started on your assignment. So this first one actually is already done for us. So of course, you know, there are some kind of like quote-unquote real-world applications here. Okay, so the first one talks about a beam from a lighthouse is visible for a distance of 3 miles. To the nearest square mile, what is the area covered by the beam as it sweeps in an arc of 150 degrees? So we kind of do like a top-down picture here, okay? We can say like the lighthouse is like right here. And that beam of light sweeps in an arc of 150 degrees. So like, you know, sweeps out like that. And so like this is like the area that the beam of light kind of covers. And so this is 150 degrees. Okay, from like here down to here, right? And then the beam is visible for a distance of 3 miles. So that 3 miles is the what? It's the radius, right? Okay, 3 miles. And so you can kind of see, okay, well, there's like the fuller kind of circle here. But we want the area of this kind of little sector there. So you can see how I set it up. M over 360 times pi r squared. So M is 150 times pi times 3, the radius, squared. And so it's about 12 miles when you do your calculations there. About 12 square miles, actually, about 12 square miles. Okay? That can, you know, that is affected by that light, the lighthouse light. That one we're not going to do because it's already kind of done for us. But the next one, and this one's kind of good to know, right? So a circular plot with a 180-foot diameter. So let's see here. So a circular plot with a 180-foot diameter. So that means we need to go through the center and hitting both sides. Okay, so the whole thing is 180 feet. A circular plot with a 180-foot diameter is watered by a spray irrigation system. To the nearest square foot, what is the area that is watered as a sprinkler rotates through an angle of 50 degrees? And so if our sprinkler is kind of here in the center, right, and it's shooting the water out, what is it for 50 degrees? So we'll kind of like draw a little 50-degree right there. Okay, so again, we'll write our formula out. Area equals pi. So, area of the sector is m over 360 times pi times the radius squared. Okay. So there it is. All right. What is our m in this case, Debbie? 50. So 50 over 360. And then what is the radius here? Let's go to Dorian. Dorian, what's the radius going to be? Is the radius 180? Is it 180? 180 goes from edge to edge. So very good, right? I do it by half. So times pi times 90 squared. Very good. All right, we got to be on our toes there. Sometimes they give us the diameter, sometimes they give us the radius. All right, so we just multiply it out. 50 over 360 times pi times 90 squared. And we get about 3,534.3 feet squared. So about 3,500 square feet, roughly. Is what that one sprinkler can cover. All right. Questions on any of that?